Hello friends, now we have completed our first chapter, that is aromatic hydrocarbons, and going towards our second chapter of this syllabus, that is alkyl and aryl halides. For moving towards our alkyl and aryl halides, firstly we have to understand the meaning of halogen derivatives of alkanes. Now, these halogen derivatives of alkanes are nothing but if we replace hydrogen atoms from alkane by the corresponding number of halogen atoms, then that species or molecule is called as halogen derivatives of alkane. Depending upon the number of hydrogen atoms replaced by halogen atoms, these halogen derivatives of alkanes are further classified into two types, that is monohalogen derivatives of alkane and polyhalogen derivatives of alkanes. Now, if we replace one hydrogen atom from alkane by one halogen atom, then that alkane is called as monohalogen derivatives of alkane. One hydrogen atom of alkane is replaced by the same number of halogen atom to give this alkyl halide as a product, which is nothing but monohalogen derivatives of alkane and is also called as alkyl halides. Now, these polyhalogen derivatives of alkane also categorized as dihalogen derivative, trihalogen derivative and tetrahalogen derivative depending upon the number of hydrogen atoms from alkanes. Depending upon the number of hydrogen atom replaced by halogen atom from alkane, it is classified into dihalogen derivatives, trihalogen and tetrahalogen derivatives of alkane. Derivatives of alkane. Now, in this case, that is in dihalogen derivatives of alkane, two hydrogen atoms from alkane are replaced by two halogen atoms. The example of these, that is ethylene dichloride. Whereas in case of trihalogen derivatives of alkane, three hydrogen atoms from alkane are replaced by three halogen atoms. The example of these trihalogen derivatives of alkane is chloroform, that is CHCl3, chloroform. Whereas, and finally, if we replace four hydrogen atom from an alkane by four halogen atoms, then we will obtain this tetrahalogen derivatives of alkane. Now, carbon tetrachloride CCl4 is an example of this tetrahalogen derivatives of alkane. Now, In this syllabus, alkyl and aryl halides are included. That's why we move towards our alkyl halides. Alkyl halides are nothing but the monohalogen derivatives of alkane in which one of the hydrogen atom from alkane is replaced by one halogen atom. Now the general reaction is shown as follows. This is the alkane. When it treated with halogen atom, one hydrogen atom from that alkane is replaced by one halogen atom to form RX as a product with the formation of halo acid, halo halide. Now, this Rx is nothing but the mono halogen derivatives of alkane, that is our alkyl halide. Now, these alkyl halides are further classified into three types depending upon the halogen atom attached to the carbon atom. Now, to understand the classification of alkyl halides, firstly we have to know about what is meant by primary carbon atom, what is meant by secondary carbon atom, and what is meant by tertiary carbon atom. A carbon atom. Now, primary carbon atom. A carbon atom to which only one carbon atom is directly attached. A carbon atom to which only one carbon atom is attached is nothing but primary carbon atom. For example, this is the carbon atom to which only one carbon atom is attached. That's why it is called as primary carbon atom. Whereas if we see this carbon atom, then this carbon atom also contains only one carbon atom directly attached to it. Such carbon atoms are called as primary carbon atoms. Now, what is meant by secondary carbon atom? In this case, if a carbon atom contains two another carbon atom directly attached to it, then that carbon atom is called as secondary carbon atom. For example, if this is the case, in this case, this carbon atom is considered as secondary carbon atom because here in this case, two carbon atoms are directly attached to this carbon atom, hence it is called as secondary carbon atom. For example, this is isopropyl bromide. In this case, this carbon atom contains two another carbon atoms which are directly attached to it. That's why it is called as secondary carbon atom. Now, next point, that is tertiary carbon atom. In this case, if a carbon atom contains three another carbon atoms which are directly attached to it. In this case, a carbon atom contains three different carbon atoms which are directly attached to it, then this carbon atom is considered as tertiary carbon atom. This carbon atom is considered as tertiary carbon atom. Now, tertiary butyl iodide. This is tertiary butyl iodide. The carbon atom on which this halogen atom is present, due to this directly attached 3 carbon atoms, becomes tertiary in nature. That's why it is considered as tertiary carbon atom. Now there is a extra carbon atom, that is quaternary carbon atom is also present. In case of, if almost all 4 valencies of this carbon atom is satisfied by 4 carbon atoms, then that carbon atom is called as quaternary carbon atom. This carbon atom is called as quaternary carbon atom. Okay, this is about the types of carbon atom. Now, depending upon these types of carbon atom, we have to explain or we have to classify alkyl halides. Now we have already know about what is meant by alkyl halides. Alkyl halides are the monohalogen derivatives of alkanes, which are obtained by the replacement of one hydrogen atom from alkane by same number, that is one halogen atom. Now these alkyl halides are classified into 3 types, that is primary alkyl halide, secondary alkyl halide, and tertiary alkyl halide. If a halogen atom is present on primary carbon atom, then that alkyl halide is called as primary alkyl halide. Or we may say that if the halogen atom is directly attached to primary carbon atom, then it is called as primary alkyl halide. Ethyl chloride is an example of this primary alkyl halide. If a halogen atom is present on the secondary carbon atom, or we may say that if the halogen atom is directly attached to secondary carbon atom, then that alkyl halide is called as secondary alkyl halide. This is isopropyl chloride is an example of this secondary alkyl halide. If likewise, if halogen atom is directly attached to tertiary carbon atom, then that alkyl halide is called as tertiary alkyl halide. If halogen atom is directly attached to tertiary carbon atom, then that alkyl halide is called as tertiary alkyl halide. Now, tertiary butyl bromide is an example of this tertiary alkyl halide. These are the classification of alkyl halides. Now, after this classification of alkyl halide, we have to proceed further towards our next topic, that is physical properties. After this alkyl halide, we have to move towards the physical properties of alkyl halides. The first physical property of this alkyl halide is nothing but the lower alkyl halides are gaseous in nature, like methyl bromide, methyl chloride and ethyl chloride. Lower members of these alkyl halides are gaseous in nature. Whereas the higher or remaining members of these alkyl halides are liquids or solids. The second property of this alkyl halide is nothing but haloalkanes, due to its higher molecular weight, have higher boiling and melting point than that of corresponding alkanes. Haloalkanes have higher melting and boiling point than that of corresponding alkanes. Due to its what? Due to its higher molecular weight. For example, N-pentane which has higher boiling point, that is 36 degrees Celsius, whereas its corresponding haloalkane, that is N-pentyl chloride, has boiling point equals to 108 degrees Celsius. The third physical property of alkyl halides is nothing but, for a given alkyl halide, if we change the halogen atom from fluorine to iodine, the boiling point also increases. As for a given alkyl group, as the atomic weight of halogen atom increases, its boiling point also increases. For example, ethyl chloride has boiling point equals to 12.2 degree Celsius, whereas ethyl bromide has boiling point equals to 38.4 degree Celsius. Now the next physical property, that is property number 4. In this case, for a given halogen atom, as the number of carbon atom increases, its boiling or melting point also increases. For example, the boiling point of ethyl chloride is 12.2 degrees Celsius, whereas the boiling point of N-propyl chloride is 47 degrees Celsius. Now the last property of this alkyl halide is nothing but, as branching increases, its boiling and melting point decreases. Due to branching, the molecule becomes spherical in nature. Due to its spherical nature, its surface volume decreases. Due to decrease in surface volume, the intermolecular forces that are present in that molecule also decreases. So, due to decrease in intermolecular forces, as branching increases, its boiling point also decreases. The example of this is as follows. It has boiling point equals to 102 degrees Celsius. It is the straight chain compound, whereas if we see this isobutyl bromide, its boiling point is equals to 91 degrees Celsius. Now due to its such branching, the boiling point, as we know that both these molecules have same molecular formula, but due to its branching, this molecule, that is alkyl halide, decreases its boiling point from 102 degrees Celsius to 91 degrees Celsius. This is all about the physical properties of alkyl halides. One more property of this alkyl halide is nothing but its solubility. due to inability of to form hydrogen bonds, these alkyl halides are less soluble or insoluble in polar solvents due to inability of formation of hydrogen bonds. These alkyl halides are insoluble in polar solvents, whereas it is soluble in non-polar solvents. Which has low polarity, like benzene, chloroform, etc. This is all about the alkyl halides and its physical properties. Okay.